Okay. Welcome. Our first problem today is integration dx 1 plus sin x by sin x into 1 plus cos x dx. This can be written as 1 by sin x into 1 plus cos x dx plus sin x by that. In that case, sin x will be cancelled, so only dx by 1 plus cos x. It is now broken into two parts, this and that. Now, first one can be written as dx by submultiple angle 2 sin x by 2 cos x by 2 into 1 plus cos x is 2 cos square x by 2 plus second one is dx by 2 cos square x by 2. It is actually 4, 1 by 4 into sin x cos cube x. So divide by 1 by 2, 1 by cos square x, 1 by cos cube x. This can be written as, this is 6, divide throughout by cos to the power 4x, so that it is sec square, sec to the power 4 x by 2. I divide throughout by cos to the power 4, and in denominator it is cos cube will be cancelled, so tan x by 2 dx plus this is equal to 1 by 2 sec square x by 2 dx. It has a formula, sec square, its integration is tan. Now this is equal to 1 by 4 into sec to the power 4 means sec square into sec square. Sec square is 1 plus tan square x by 2 sec square x by 2 dx by tan x by 2 plus this is sec, only sec square x dx is tan x, the sec square x by 2 here also half, so it is equal to tan x by 2. So that in that case here we put tan x is equal to z, so sec square x by 2, from there we get tan x by 2, so half sec square x by 2 dx is equal to dz, so that it is equal to 1 by 2. A 2 will be there, so 2 and 1 by 4 is half into 1 plus z square, 1 plus z square, this is z square, sec square x by 2 dx is 2 dz, 2 is there, so this by that dz plus tan x by 2. It is equal to, in first part 1 by z dz, half log z plus next one is z square by z dz, so z dz, so z square by 2, so that 1 by 2 into 1 by 2 z square plus z square tan x by 2 plus c, so that it is equal to half log of mod z. Z means tan x by 2 plus 1 by 4 z square is tan square x by 2. 1 by 4 tan square x by 2 plus tan x by 2 plus c. And this is our answer. So, okay. Our next problem, integration, just 1 minute. Integration dx by 1 plus sine square x. It is of the type in denominator, it is second degree homogeneous in sin x and cos x. Actually, this is second degree, and 1 can be written as sin square x plus cos square x. So they together is quadratic, homogeneous quadratic in sin x and cos x. So it has a sin square x plus cos square x plus sin square x. That is, it is equal to dx by 2 sin square x plus cos square x. It has a definite form, but it is a definite form, divide throughout by cos square x. Then we get answer. How? It is equal to, if I divide by cos square x, so it is equal to sec square x dx by 2 tan square x plus 1. Now, if I put tan x is equal to z, then sec square x dx is equal to dz. In that case, derivative is ready here. This is the case when denominator can be expressed as quadratic in sin, homogeneous in sin x and cos x. Then only we divide throughout by cos square x, and we get that derivative is ready, will be there, dz by 2z square plus 1, and it has a definite formula. It is 1 by 2. First you make z coefficient of z square 1, so that dz by z square plus half. Half is nothing but 1 by root 2 whole square. So it is of the type dx by x square plus a square. So it is equal to, its formula is dz by z square plus a square 1 upon a. 1 upon a is 1 by root 2. 1 upon a tan inverse z by a root 2 z, so that plus c, so that it is equal to 1 by root 2 tan inverse root 2 z means tan x plus c. Next, problem is cos x by 2 sin x plus 3 cos x. It is of the form, in numerator, it is linear in sin x and cos x. Here sin x, coefficient of sin x is 0. So linear in sin x and cos x in numerator, and linear in sin x and cos x in denominator also. In that case, we have to take numerator as some constant L into denominator intact, 2 sin x plus 3 cos x plus another constant n into derivative of the denominator, that is 2 cos x minus 3 sin x. Now let us take cos x is equivalent to that. Now from there we can very easily obtain a value of L and M. Knowing value of L and M, the integration is equal to this divided by that plus this divided by that. In first case, this divided by that, L is a constant, it can be taken outside, so simply dx. This and that will be cancelled, so x plus another, this constant m, knowing the value of m, it can be taken outside. Then this by that, its derivative is ready there. Its derivative is 2 cos x minus 3 sin x. So it is of the type dx dz by z. So both parts can be integrated very easily. So how to find the values of L and M? From both sides, equating coefficient of sin x, here 0 in denominator, sin x is 0, 2L minus 3m, sin x is 3m, and equating coefficient of cos x also, 1 in left side, and this is 3L minus plus 2m. So from these two, very easily we can find the value of the constants L and M. From here, M is equal to 2 by 3L. M is equal to 2 by 3L, put it there. So this is equal to 3L plus 2 into 2 by 3L. So that it is equal to 9 plus 4, 13L by 3. So we get L is equal to 3 by 13 and M is equal to 2 by 3 into 3 by 13. So that 2 by 13. So L and M are obtained very easily. So that now this is equal to this, cos x is that divided by this. So integration is equal to, first of all, this divided by that, that is L into 2 sin x plus 3 cos x dx by 2 sin x plus 3 cos x, then plus m into 2 cos x minus 3 sin x divided by 2 sin x plus 3 cos x dx. Now put the value of L and M. L is equal to 3 by 13 into this by that, they cancel, so simply dx plus M. M is 2 by 13 integration. If you take this is z, then its derivative is 2 cos x plus derivative of cos x is minus 3 sin x. So this is, if we put 2 sin x plus 3 cos x is equal to z, then its derivative is that. So m into dz by z, so that it is equal to 3 by 13 x plus 2 by 13 log of mod z. Z is nothing but what I have taken. Z is equal to this 2 sin x plus 3 cos x plus c. This is answer. Mind that the value of L and M, you must find their values accurately. If there is any mistake for the whole work, you will get 0. If it is not correct, L and M to be determined accurately means correct way. Otherwise, you will be given only 0. So this is your answer. Process is very simple. What is the format? In numerator, linear in sin x and cos x, and in denominator, linear in sin x and cos x. So in that case, we have to take numerator is equivalent to some constant into the denominator plus another constant into derivative of the denominator. Then equating coefficients of sin x and cos x from both sides, you can very easily obtain values of L and M. After that, it will be L into x will be always there plus M into log of the denominator. This next. Next problem is integration root over tan x plus root over cot x dx. This can be taken as it is root over sin x by cos x plus root over cos x by sin x dx is equal to, in numerator, root sin x into root sin x, that is sin x, plus root cos x into root cos x by under root sin x into cos x. Now let us try to express this by adding or subtracting 1 from here. If first of all make it 2, if it is okay, it is integration root over of 2 sin x cos x. So I have taken root 2 in denominator, so here also root 2 sin x plus cos x. So if I take, we know that it is derivative of what? Sin x minus cos x. Its derivative is cos x plus sin x. Sin x, we try to express this as function of that. How? Now it is equal to 1 minus that. You see, 1 cancels, this become plus 2. It was plus 2. So, and take 1 dx, so that it is equal to root 2 into sin x plus cos x divided by root over of 1 minus, this is actually get together, it is sine square x plus cos square x minus 2 sine x cos x. So it is equal to sine x minus cos x whole square dx. This is 1 sine square plus cos square is 1 minus product term is that. So we get that. Now we put sin x minus cos x is equal to z. So cos x plus sin x is equal to dz. So that it is equal to root 2 into this become dz by root over 1 minus z square. So it's a standard form. It has a definite formula and it is equal to root 2 sine inverse z by 1, z by a. So sine inverse z plus c. So that it is root 2 sine inverse z means sine x minus cos x plus c. I think this is the correct answer. This is correct answer. This is answer. Next. Now the next problem is integration x to the power x into 1 plus log x by x to the power 2x plus 4 dx. Achha. You see this is x to the power x whole square plus 2 square of that type. For that purpose put x to the power x is equal to t or z. Its derivative directly is not possible. So take log x log x is equal to log z. So that 1 upon z dz is equal to derivative of that 1 into log x plus x into 1 by x. So 1 into dx. So that dz is equal to z into that. Z means x to the power x 1 plus log x dx. So you see we get x to the power x into 1 plus log x dx is dz. So this is dz by. So that dz by this is x to the power x whole square means z square plus 4 to square. It's a standard form and its formula is 1 upon a tan inverse z by a. Z means z by a is 2 plus c. So that half tan inverse z is your x to the power x by 2 plus c. This is answer. Next problem. Next problem is integration x to the power half by x to the power 3 by 2 plus x to the power 4 by 3 dx. The type is in numerator and denominator, all powers of x are fraction. So we have to put, first of all, you see what is the LCM of denominator of the powers. First one is 2, denominator. It is again 2 and it is 3. So LCM of this 2 and 3 is 6 in fact, 6. Put x is equal to z to the power 6 so that all powers will be integer. And in that case, it is dx is equal to 6 log of z, oh sorry, just 1 minute. It is 6 z to the power 5 dz. So that it becomes x to the power half. X to the power half is z to the power 3, z cube. Dx is your 6 into z to the power 5 dz by, this is x to the power 3 by 2, x to the power 3 into z by 3 by 2. So it is equal to x to the power half, it is your z cube, z to the power 6 plus, it is 8, z to the power 8, just 1 minute, it is x to the power, x is your z to the power 6, so 6, okay. Now we can cancel z to the power 6 from both numerator and denominator. If it is okay, then you cancel some powers of z from numerator and denominator, 6, and it is actually z to the power 8 and z to the, so cancel by z to the power 6. So z square by 1 plus z square dz. Now it is very simple. It is equal to 6 into 1 plus z square minus 1 by 1 plus z square dz. So the first integral is this by that is 1 dz. So 6 into dz minus 6 into 1 by that dz by 1 plus z square. So that 6z minus 6, it is of the type dz by z square plus a square, 1 upon a tan inverse z by 1 plus c. Now put value of z. Z means x to the power 1 by 6. So x to the power 1 by 6 minus 6 tan inverse plus c. Let us see what is the result. Six anyway, okay. So let us stop today. Next day we take many more problems. Thank you.